Hello everyone, my name is Ashley Goodnight and this is my Lab 4 presentation. First, let's move to the introduction. The purpose of this lab is to predict the motion of an oscillating spring mass system using energy and comparing the results to the actual observed motion data. We care about the conclusions and results of this lab in order to apply our knowledge of the main physics principle, the energy principle, and in order to gain experience taking real observed motion data and finding the forces and now energy behind it. Now on to the summarized results. Here's a more in-depth summary of my results. In GlowScript, I successfully created a model of the spring mass system oscillation over time. When comparing my predicted motion to the observed data, there were minor discrepancies due to uncalculated work components from forces such as air resistance. Let's take a look at the observed data. Here we can see the tracker program with the inserted clip. I copied the position data and turned it into a spreadsheet with a CSV file for the code. Speaking of the code, let's look at the main assumptions. In the code, we used energy, so here are the equations I used to represent the energy principle with gravitational potential energy, spring potential energy, and kinetic energy. For spring potential energy, we need to solve for K and L naught. Solving for the spring constant, I used the equation for the period of the oscillation t. I estimated t by looking at my observed motion. With the given measurement of mass, I calculated k to be equal to 6.88 newtons per meter. For L naught, I used the equilibrium point of the force of gravity and the spring force. This resulted with L naught equaling 0.127 meters. Let's see how these values went into the code. In this first section, I added the initial conditions for mass, position, velocity, and the spring. Next, I put in the code for the energy principle. Then, I added the code for the net force and the momentum principle. Finally, I created the part for the change in energy and plotting the graphs. Let's look at the results of the code. Here are the GlowScript results. I uploaded the CSV file of the tracker data, and here's the animation of the motion. Let's look at the plots underneath. Here is the energy graph. Notice that while all of the components, kinetic and potential energy, fluctuate over time, the total energy is 0. This means that the energy principle was satisfied, right? Well, in theory, if the net change in energy is 0, then yes. However, our estimate of the change in energy is sometimes non-zero. This is due to unpredicted forces doing work. This is specifically drag or air resistance. Furthermore, this is a dissipative force, so the energy is lost as heat to the surroundings. Let's look at the other motion graph from GlowScript. Here is the observed versus predicted plot. As you can see, they are the same motion, but slightly off. This is likely due to multiple reasons. A major one is that these values are so tiny, so when making the centers of mass, I could have been slightly off every single time, accounting for the tiny shift. Lastly, we addressed comparisons in the calculated period for the x and y direction. Here are the periods using the GlowScript code. I initially used the x direction, but let's look at the final observed versus predicted graph if I use the y. The error is significantly more, so I'm happy with my choice of using the x direction. With that, I conclude my presentation. Thank you for watching.